Now we're going to use what we learned about a heating curve in order to solve a problem which I have listed below. So as you read the problem, it says find the heat required to change 40 grams of ice at -5 degrees into steam at 100. The first thing you need to do when you solve a problem like this is find out where on this map you're starting and where on the map you're ending. So we're starting with an ice cube at -5 degrees. -5 degrees is definitely in zone 1, so we're starting right about there. Okay, I'm going to call this zone 1, 2, 3, 4, 5. Now we're going to be steam at 100. Steam, remember, is a gas. So we're gas at 100 is going to be right here. That's between zones 4 and 5. Now if this had said instead of steam, it said water at 100 would have been right here because this is the liquid section and this would be the top. But this is steam, so you have to really read the problem carefully. So now you see that this problem has a zone 1, a zone 2, a zone 3, a zone 4. There are actually 4 parts to this problem, and we're going to solve each zone as they come. So let's start with zone 1. Zone 1 is going to be the slant. The slant is always Q equals MC delta T. So I'm going to write that over here. Q equals MC delta T. I'll write the C in red to remind you that you're just going to copy down the red number for that zone. So while we're here, the red number is going to be 2.0 joules per gram degrees Celsius. That's the number I have for the specific heat of ice. Now we need to know the mass of the ice. The mass of the ice is 40 grams. So I'm going to write 40.0 grams. The delta T is only for this zone, the change in this zone. It goes from -5 to 0, so that's a change of 5 degrees Celsius. You could just do absolute value for that. Okay, lost the page again. Okay, so we're going to go here. That's going to be 5.0 degrees Celsius. So 5.0 degrees Celsius, and when you do the math for that, you're going to get 400 joules as your heat for zone 1. Okay, so now you've gone to zone 1. Now we're going to move to zone 2. Zone 2, the equation is just Q equals MC. So for zone 2, we're going to write Q equals MC. And the C we're just going to copy off of our chart. And again, that C is 334 joules per gram to melt ice. The mass of the ice is still 40. So we're going to write 40 grams as our mass. And when you multiply this out and round it, you're going to get 13,360. So there's my zone 2. Now I'm going to move on to zone 3. Register there. 13,360 joules. Okay, zone 3 is going to be in the water section. So water is going to heat up. So it's going to be a Q equals MC delta T. And my C value for that zone is going to be 4.18 joules per gram. The M is still going to be 40 grams. And the delta T for this zone is actually going to be the whole zone. Because look, we're going from 0 all the way to 100 because I'm going to eventually go over here. So that's the complete zone right there. 100 degrees Celsius is the total. So 100 degrees is the change. And now when you do the math for that, you're going to come up with 16,720 once you rounded it. So 16,720 joules is the answer to this. And last but not least, we're going to go to zone 4. And we're just going to squeeze that in over here on our calculations. So zone 4 is going to be just the steam heating up. I'm sorry, just the water boiling is what we want to say. Just the water boiling. So 4, it's going to be Q equals MC because we're not changing the temperature. We're not changing that at all. We're just changing the state. So it's just going to be MC. Now you copy down your C. And your C for that section is 2260 joules per gram. the mass is still going to be 40 grams. And once you get that, you do your math, and you find out that it comes out to be 90,400. 90,400. Let's try to let this catch up to me here. So 90,400 joules. So for this whole process, how much energy did it take? You just got to add up all the numbers. And when you add up all the numbers together, you get 120,880. So 128.80 joules, which is the same as 121 kilojoules. So that's how much energy is going to take to get all these processes to occur for 40 grams of ice. All right, now look, if this had just said, what is the heat required to change 40 grams of ice at -5 Celsius to water at 100? Water, this is what I pointed out before, then this would only be zones 1 plus zone 2 plus zone 3. Okay, so we're adding all these before, this plus that. Now we're just going to add 1, 2, and 3. And if you do that, your answer is going to be 30,480 joules, which equals 30.5 kilojoules. So read the problem carefully. This problem ended at steam at 100, but if it ended at water at 100, it would have been right here, and it would have just been zones 1, 2, and 3. So read the problem carefully. It could be a 1 zone, 2 zone, 3 zone, 4 zone, 5 zone problem. You just add up all the answers, and that's going to give you the total for